Welcome to the lecture on electrical circuit analysis. So, today lecture is on duality and dual networks. So, how to solve the problems on the concept of duality. So, we are going to solve some problems on this duality concepts. Okay. So, the learning objectives of this today lecture is to draw the dual network for any given network. So, what is the procedure to draw the given network to draw the dual network for the given network? Let us see in this lecture. And the next objective is to solve the problems on dual networks. Okay. So, how to draw the how to convert the given network into dual network. Okay. So, let us see example problem. So, we know that when the two electrical circuits are duals, so if the mesh equations characterize the one of them have the same mathematical form as the nodal equations that characterize the other network, other circuit, then these circuits are said to be duals of with each other. Now, see this network, this circuit, first one. So, voltage source, resistor, inductor, capacitor, these three are connected in series. Apply the KVL in the series connected elements. Okay. The voltage across the inductor is L into di by dt, LA into di by dt plus the voltage across the resistor is V is equal to IR, Ohm's law. So, RA into IA plus the voltage across the capacitor. So, 1 by CA into integral of IA into dt, that must be equal to the applied voltage is equal to VA, or minus VA is equal to 0. Now, these when can I say that these networks are duals of with each other? Now, see this voltage source replaced by a current source, resistor is replaced by conductance G. So, while we already discussed in the last class the pairs of duals, dual pairs. Okay. Next, inductor is replaced by capacitor and capacitor replaced by inductor. Now, as these elements are connected in series, now we have to convert this in the parallel. So, apply the Kirchhoff current law at this node. Okay. Now, this is only one node, amma. This is only one node. So, this is only one node. Okay. This is entire is only one node it is. So, if you apply the Kirchhoff current law, so what is the current flowing through the capacitor? We know that I is equal to C into dV by dt. Therefore, Cb into dVb by dt, that is Vb is the voltage across the inductor, plus what is the current flowing through the conductance? I is equal to V by R, but with the current flowing through the conductance Z is equal to voltage into conductance Vz. Okay. So, Gb into Vb plus current flowing through the inductor 1 by LA into integral of Vb dt. So, that is equal to this current source Ib, or minus Ib is equal to 0. So, therefore, these the equations form, mesh equations formed by this given network, this let us say network A, this is a mathematical equations look like so look like this network Kirchhoff current law, KCL equations. So, these two equations are duals of with each other. So, I told you two electrical circuits are duals if the mesh equations that characterize the one of them have the same mathematical form as the nodal equations that characterize the other. Therefore, these two equations are duals of with each other. So, this is the concept of duality. Now, what is the procedure for conversion of the dual network? Okay. So, let us see in this lecture. So, instead of reading this procedure, so I have taken one example problem to explain you. Okay. So, for the network bridge network shown in below, to draw its dual network, write the differential form of the mesh equations for the given network and node equations for its dual network. So, once you obtain the dual, once you draw the dual network for the given network, so we have to write the node equations. So, the values for resistor in ohms, capacitors are in farads, inductors are in henries, and voltage is 10 sin 50 t. That means, for this network we have to draw the dual network. So, this is our dual network. See this dual network. So, this is the dual network for the given network. So, how we obtain this? What are the different steps to follow to draw the dual network? Now, see, to understand that I have taken the steps. First step is put a dot in each independent loop of the network. So, these dots correspond to independent. Now, see here. What is the first step? So, put a dot in the each independent mesh. So, first mesh is I put a one dot here. So, second mesh I put another dot here, third mesh I put another dot here. Okay. So, 3 dots are there. So, 3 dots completed. Now, next one is what? Second step, I am going back. Second step is put a dot outside the network. So, this dot corresponds to the reference node in the dual network. See here, I put one dot in the outside. So, let us say this is one dot. Let us say this is one dot outside, because to connect the reference. Now, second point is over. Now, third step. What is the third step? So, connect all internal dots in the neighboring loops by dotted lines, cutting the common branches. You have to eliminate the common branches. You have to cut the common branches. We have to join the, we have to add all internal nodes. You have to connect all internal dots in the neighboring loops by cutting the common branches. So, these branches that are cut by dotted lines will form the branches connecting the corresponding independent nodes in the dual network. Now, see here. So, I am explaining here. Now, see how we are drawing. See. So, this node is there, first node. Okay. So, between this first node and second node, okay, what are the elements between the first mesh and second mesh? So, 1 Henry inductor. So, 1 Henry inductor is replaced by 1 farad capacitor between the first node and second node. Next, between the first mesh and second third mesh, so 4 farad capacitor is there. So, this replaced by, so between the first node and between the third node, so replaced by 4 Henry inductor. Now, this 10 ohm resistor, okay, this 10 ohm resistor replaced by 1 by 10 conductance, 1 by 10 conductance. Okay. So, therefore, the first node and 1 by 10 conductance, this one. So, this is replaced by this one. How to draw the dual network? Next, these two between the mesh 2 and mesh 3, okay, between the mesh 2 and mesh 3 there is a 5 farad capacitor is there. Therefore, between these two with node 2 and node 3 there should be 5 Henry inductor. You have to draw the 5 Henry inductor between the 2 and 3 nodes. Okay. Next, for the mesh 2 only there is a independent element is there, that is 2 Henry inductor. So, this 2 Henry inductor represented by, so 2 farad capacitor. Okay. This is the node 2 and the reference node, because it is only independent element it is. So, you have to connect to the node 2 and the independent is nothing but our reference node. If it is independent means you have to connect to the that corresponding node and the reference node. Now, see here between this mesh 3, so 3 ohm resistor is there. So, we have to connect to these 1 by 3 mhos, 1 by 3 mho, the units for conductance is mho, 1 by 3 mho conductance you have to connect to the third node and the reference node, because it is independent element. Of course, this capacitor always already we have connected between the node 1 and node 3. So, capacitor replaced by inductor, 4 Henry inductor. Now, voltage source is there. Now, see fifth point, you see the fifth point, okay, conversion of for source in the dual network. See, clockwise current source in a loop corresponding to its a voltage source with positive polarity at the dual independent node. If it is a voltage rise in the direction of a clockwise, if it is a current source, you have to draw the voltage source. If it is a clockwise current source is clockwise, you have to draw the voltage source with positive polarity. So, if it is a voltage source is there, okay, if the voltage source is that is positive polarity, then you have to draw the its equivalent current source. So, that means the current source direction is upwards, that is the rising direction, current must be rising. So, therefore, I have drawn this the voltage source, its equivalent voltage source, I have drawn current source. See, because this is the first voltage source in the first mesh, so I have connected this to the first node, okay, I have connected to the node 1 and the remaining go to the reference node. Okay. So, this is what the steps to follow to draw the dual network for the given network. And also, see, I have taken the only one element is connected, But if this branch C, this instead of this inductor, so there is inductor is there, capacitor is there in series. Then how? So this series combination will become a parallel combination for the dual network. So that's what the fourth point here. Okay. So as an example, if a common branch contains R and L in series, so then the parallel combination of G and C should be put between the corresponding independent nodes in the dual network. Now once you did that, so join all internal dots to the external dots. So this is happened. Okay. Once you have to add all these dots. So you have to add all these dots. So this your internal dots you should connect to the external dot, to dotted lines, through dotted line. That's what the fourth point. Join all internal dots to the external dots by dashed lines cutting all external branches. So duals of these branches cut by dashed lines will form the branches connecting the independent nodes and the reference node. Okay. So that's the reason I have drawn there. I have joined these all the dots. Okay. So if you join that, then you will get this network. So this network and this network are both same. Instead of dotted lines, so I have done a thick line, but proper arrangement. Now see that network and this network. Okay. Now see in this network, okay, voltage source is there, in series the resistance. Okay. Now see here, current source is there in parallel with the conductance. Between the mesh 1 and 2, there is a 1 Henry inductor. Now here, between the node 1 and 2, between the node 1 and node 2, there is a 1 farad capacitor. Okay. Now between the node 1 and node 3, sorry, mesh 1 and mesh 3, mesh 1 and mesh 3, so 4 farad capacitor. But see here, between the node 1 and node 3, 4 Henry inductor. Next, between the node 2 and mesh 2 and mesh 3, 5 farad capacitor. But see here, between the node 2 and node 3 here, 5 Henry inductor. Now independent elements are same. Independent is 2 Henry inductor in the mesh 2, 3 ohm resistor in the mesh 3. Now here, see here, 2 farad capacitor is a node 2 connected to the node 2, and 3 ohm 1/3 ohm conductance connected to the node 3. So this is what the equivalent circuit, that is a dual network. How to draw the dual network for the any given network. Now in the question, you asked that write the differential equation for the given network, that is mesh equations, and write the node equations for the its dual network. Now see here, what is the mesh equation for this network? So we already apply the Kirchhoff voltage law in the each mesh, you will obtain these equations. So let me try the first mesh equations. Voltage across the resistor is 10 into I1 plus voltage across the inductor 1 into d by dt is d, I1 minus I2, I1 is entering, I2 is leaving, plus voltage across the capacitor 1/4 into integral of I dt, 1/4 into I1 minus I3 into dt is equal to 10 sin 50t. That is Kirchhoff voltage in the first mesh. Now apply in the second mesh and third mesh, you will get these equations. So these equations, these mathematical equations must look like same these equations, see here. So this one. Once you draw the dual network, you have to write the node equations. That means you have to apply the Kirchhoff voltage current law KCL for all the nodes. So node 1, what is the node 1? Apply the algebraic sum of the currents leaving the junction is equal to 0, or sum of the currents entering into the node is equal to the leaving the node. See here, V1, see this is node 1 V1, okay, node 2 V2, node 3 V3. Okay. So I am applying, let us say I am applying here node 1. What is the current entering? 10 sin 50t is entering. So 10 sin 50t must be equal to the. So what are the currents leaving? The current leaving here, how much? So V1, this is conductance, the 10, 1/10, not inductance, not resistance, therefore V1 into 10. Okay, V1 into 10, so 10 V1, okay, 10 V1 plus what is the current flowing through the inductor, current flowing through the capacitor, I is equal to C into dV by dt. So therefore I is how much, C is how much, 1, so 1 into dV by dt, so d into V by d by dt is d here, 1 into d into V1 minus potential difference V1 minus V2, okay, second node V1 minus V2. So, d into V1 minus V2 plus what is the current flowing through the inductor, 1 by L into integral of V dt. Therefore, 1 by 4 into integral of V1 minus V2, V1 minus V3, because this inductor is connected between the node 1 and node 3, V1 minus V3 into dt is equal to 10 sin 50t. Now, apply the Kirchhoff current law for the node 2 and node 3, then you will get these equations. So, this first equation is a dual of this first equation. The second equation, second mesh equations is dual to the second node equations, that is node KCL equation for the node 2. Here node 3 equation is here mesh 3 equation. So, these 3 equations are forms a dual sub with each other. Okay. So, this is the way how to convert how to draw the dual network for the given network. Okay. So, thank you for listening the class. We will join in the next class. Thank you.